Again, separable means that we can separate the x's on one side and the y's on the other. Well, I suppose I could move this to the other side so that we would have dy dx is equal to a negative e to the x plus y. And then somehow I need to separate the x's and the y's there. Well, you can use the rule about exponents that if the bases are the same and you're multiplying, then that's when you add exponents. So you can get them separated that way. The next thing to do would be have the y stuff on the left-hand side. So we would have dy divided by e to the y equals negative e to the x dx. And then integrate both sides. Well, the way that this one's written, it's not really that easy to integrate, but if you just rewrite it as e to the negative y dy, then it'll be cinchy. So this one, the antiderivative of e is e, but then because the exponent is negative, if you use the chain rule, the derivative would be a negative 1, so we need a negative 1 here. And then this one turns out to be negative e to the x plus c. Let's see, we could get rid of negatives. We would have e to the negative y equals e to the x minus c. Now I need to solve for y, so eliminate this e by taking natural log of both sides. And be sure to put the whole right-hand side in parentheses. So on the right-hand side, because of that minus c, these guys are not going to cancel. Over here, because there's just natural log and e, those can cancel. So then we would have negative y, my goodness, that's a big negative sign. Negative y equals the natural log of e to the x minus c. Last, move the negative to the other side, and we're done. This one doesn't have any initial conditions saying something like y of 0 equals 5 or something like that in order for us to find c. So you just use it, leave it like that.